we're at gotomath.com working some calculus problems. Let's click on the calculus button there. We're actually in the section on the numerical approach of finding the limit. And we're doing 3.4, and there it is, popped up. Alright, it says evaluate the limit numerically. We got the limit as x approaches 2 of x minus 2 over x squared minus 4. So let's head over to the whiteboard and take a look at this. Nice clean board. We have the limit as x approaches 2 of x minus 2 over x squared minus 4. I'm going to skip a lot of stuff going on that I talked about in the other videos that you might want to see, and that would be 3.1, 3.2, 3.3 in this section. But to evaluate this numerically, what we want to do is we want to just simply do this. We're going to come in from the left hand side, and that means we're going to take 1.9 and plug it into the function. Now of course you're probably wondering, what is the function? Well, it's really this up here, x minus 2 over x squared minus 4. Okay, so that's our function right there. I mean, this question could have been asked, or I say questions, it could have been set up like this. Alright, find the limit of f of x approaches 2, and then f of x is defined up here. But we wrote it all in one single thing right here. It's normally written like this. But anyway, so to find out what this limit is numerically, what we're going to do is we're going to come in from the left hand side at 2, right, and that means 1.9, and we just plug it in. That's all you got to do, right? So doing this stuff numerically is actually pretty easy stuff to find out what this limit is. And then what we'll want to do is get a little closer to 2. So 1.99 is a little closer to 2. 1.99 minus 2 over 1.99 squared minus 4. Now, if we, let me just go back here real quick and say something. If we did what's called direct substitution, and direct substitution states that we just take 2 and plug it directly in. Okay, we'd be plugging it directly into this guy, and what we end up with is 0 over 0. Of course, it's planned that way in these problems. Is we end up with 0 over 0, and that's not good. So in order to find out what this limit is actually approaching, we could do it numerically. Okay, even though there is another technique, but this is, we're trying to get an idea here of what this limit thing's all about. All right, now we're going to come in from the right hand side, and of course we're going to get close to 2 coming in from the right. That'd be 2.1. So we got 2.1 minus 2, and then we do 2.1 squared minus 4 in the bottom, right? And so we write that number out. And then let's just continue this right over here. F of 2.01. Right, so we take 2.01 and minus 2, we just plug it in to the function there, and 2.01 squared minus 4. So we get our calculator out, or you can do it by hand if you're bored, and look at that number. So we look at these numbers here, and we want to compare them, right? So we want to compare coming in from the left hand side, I say, we want to compare that, right? So we think it's, some number A, and then coming in from the right hand side, right, that was this guy here, and you know what, I'm going to put an arrow like that and say, we'll say that number's B. But if it looks like A is equal to B, right, then we could say that the limit as x approaches 2 of this guy is equal to A or B, or as long as they're both the same. All right. So that's all there is to finding the trying to evaluate the limit numerically. Now let's just move over here and let me hit the help button here and see what's going on. So as you can see here, this now this is going out way out here, and I'm not intentionally doing this, but this is just JavaScript for us and the scripting code that makes all this possible. And I'm not rounding to any specific number, just, let it go out, whatever. Uh, and so we got 0.26, 0.25, 0.25. So as you can see here, it's looking like it's converging towards 1/4 is what it's looking to me like. It's converging towards 1/4 to be more precise instead of 0.25. And of course you can see coming in from the right hand side, right, 0.23, 0.24a, 0.249, right? So we can kind of see that it's, and you can see this right here. There is some stuff down there written, talked about, but anyway, you can see that it looks like it's converging towards 1/4, and of course it is. All right, so there it is. Remember where you are. All right, I'll see you there. Bye.